Hello, welcome back to my channel. In this video we want to discuss absolute values inequalities or inequalities with absolute value. So at the end of this lesson you should be able to apply the rules of absolute value to solve inequalities. Okay, so remember to like this channel and click the subscription button below. God bless you. So our objectives for this lesson are solving equations involving absolute value, that is inequalities particularly, and solving inequalities involving absolute values. Okay, so we have theory number 1. So there are theorems guiding the application of absolute value in inequalities, and the first theorem states that if a positive real number, if a is a positive real number, that is if a is greater than 0, and if u is any algebraic expression, then absolute value of u equals to a is equivalent to u equals to a or u equals to minus a. So these are the conditions guiding the operation of these rules. Okay, we have these conditions guiding the operation of number 1. This, to apply this rule, you must know that a is greater than or equal to 0. Okay, so your a must be greater than or equal to 0. Okay, so that is the first thing. A must be greater than or equal to 0. Okay guys, so as we are saying, our condition 1 is a must be greater than or equal to 0. Condition 2 for this rule, if absolute value of u equals to 0, then u equals to 0. That is the next condition. Then the third condition is that if you have absolute value of u equals to minus a, then the inequality has no solution. Okay, this kind of inequality has no solution. So these are the conditions guiding the operation of this rule. So if absolute value of a is equal to a and a is a positive real number, then u equals to a or u equals to minus a. Examples of the application of this inequality is given as this one. Find the real solution if any of the following. Okay, find the real solution of the following. Number 1, find the real solution of absolute value of 2x equals to 6. Okay, so comparing with what we have there, it goes with u equals to a, where a is greater than 0. Of course 6 is greater than 0 here, so it works. So we then say therefore 2x equals to 6. Dividing both sides by 2, we have 2x over 2 equals to 6 over 2. So that gives us 3. So multiply x equals to 3. Okay, or we take the other side, 2x equals to minus 6. Dividing both sides by 2 as well, over 2 minus 6 over 2. So this one will give us minus 3, and then we have x equals to minus 3. So the solution set of this inequality are x equals to minus 3, 3. Okay, and that solves the equation of the inequality. Okay, example 2. Consider this inequality. So for example 2, we have consider this inequality here. Okay, 1 minus absolute value of 1 minus 40 plus 8 equals to 13. So we want to apply theorem 1. So first of all, we'll subtract 8 from both sides. So subtracting 8 from both sides will give us absolute value of 1 minus 4t equals to equal to 13 minus 8. 13 minus 8 is 5, guys. So we have 5 there. So apply the rule. We have 1 minus 4t, because 5 is greater than 0, of course. 1 minus 4t equals to 5, or 1 minus 4t equals to minus 5. So we solve both sides. So subtracting 1 from both sides, we have minus 4t equals to 4, and dividing both sides by minus 4 will give us t equals to minus 1. Okay, or subtracting 1 from both sides as well. Okay, we have minus 4t equals to minus 6, and dividing both sides by minus 4, we have this cancel this, therefore t equals to minus is plus, 2 here 2, 2 here 3 over 2. Okay, which is the same thing as 1.5. So the solution set of this inequality is minus 1.5, and that solves the problem, guys. Okay, example 3. For example number 3, we have something like this. Absolute value of minus 2x equal to 4. Okay, so now you can see x is the algebra here. It is not inside the absolute value symbol, and absolute value of a number is the same thing as that number. So absolute value of 2 equals to minus 2 square root, which is 2. So here, guys, we have 2x equals to 4. So dividing both sides by 2, that will give us x equal to 2. And that is the solution, guys. Example 4. Absolute value of x over 3 plus 2 over 5 equal to 2. Okay, equal to 2. So what we can do is simplify the absolute value first. Lowest common multiple of 3 and 5 is 15. Okay, so 3 and 15 we have 5x, and 5 and 15 we have 3, which is 6. So equals to 2. Okay, so applying the rule of absolute value to this one, we have 5x plus 6 over 5 equals to 2, or 5x plus 6 over 5 equals to minus 2. Okay, because 2 is greater than 0, of course. So if we cross multiply here, we have 5x plus 6 equals to 10. So 5x equal to 10 minus 6, which is 4. So dividing the side by 5, we have x equals to 4 over 5, or here multiplying by 5, 5x plus 6 equals to minus 10. Okay, so taking 6 to the other side here become minus, so this is minus 16. Dividing both sides by 5 give us 5 here, 5 here, that's minus 3, or whole number 1 over 5. Okay, and that can be written as minus 3.2. So therefore the final answer to the question is that the final answer to the question is x equals to the set 3.2, or changing this one to, we have 0.8, because 4 over 5 is 0.8, of course. And that answers the question. So final example on this one, we have example 5, which can be written as 4 minus absolute value of 2x equals to 3. Okay, so this can be written as, okay, we can subtract 4 from both sides. Subtracting 4 from both sides will give us 3 minus 4, so which is the same thing as absolute value of 2x equals to minus 1. So dividing both sides by minus 1, we have absolute value of 2x equals to 1, and of course 1 is greater than 0, so 2x equals to 1 imply x is equals to 1 over 2, or 2x equals to minus 1 imply x equals to minus 1 over 2, and therefore x equals to the set minus 1 over 2 or 1 over 2, and that answers the question. So this is how to solve inequality of this nature. So moving to the next theorem, theorem 2 and 3. Okay, so look at this theorem. If a is positive number and u is an algebraic expression, take note, u must be an algebraic expression. Okay, then absolute value of u less than a implies a is greater than, or u is greater than or equal to minus a, and less than a. So it work for strict inequality, strictly less than, and also work for slack less than or equal to. So it works. So in other words, if absolute value of u is less than a, then u is greater than minus a and u is less than minus a. So you have a combined inequality whenever you have this theorem in operation. So let's see if we can get an example of this kind of inequality. Examples. So consider this example. Okay, solve the inequality and express your answer using set notation or interval notation and graph the inequality. Okay, solve and graph your solution. Okay, so for number 1, we have absolute value of x less than 8. So the first condition to look at is that a must be greater than or equal to 0, and here 8 is greater than 0. So we can apply the rule here. So we now say our absolute value of 2x less than 8 implies 2x is less than minus 8 is less than 2x and less than 8, because the inequality is straight, so it's going to be straight on both sides. So we solve it the way we solve compound inequality. Divide through by 2, we have minus 8 over 2 less than 2x over 2 less than 8 over 2. So we have minus 4 less than x less than 4. Okay, so graphing this inequality, we have a number line of this form: minus 4 here, 4 here, we have a circle here, we have a circle here, and then we join it together. So this region is x less than 4 and greater than minus 4, and this is the x-axis, and the circles are unshaded because the inequality is a straight inequality. Another example, example 2. Absolute value of x minus 2 plus 2 is less than 3. Okay, so the first thing we do is to subtract 2 from both sides. So that will give us x minus 2 less than 3 minus 2, which is 1, and of course 1 is greater than 0, so it works. So we have x minus 2 greater than minus 1 and less than 1. So we solve it compoundly, add it all through. Okay, and that will give us minus 1 plus 2 less than x minus 2 plus 2 less than 1 plus 2, and this is 1 less than x less than 3. Okay, and on the number line we can plot the inequality graph does. Straight inequality, the straight, so we join -1 to 1, and this is x greater than 1 and less than 3, and this is 1 and this is 3, and this is the x-axis. We have the inequality plotted that way. So final example on this note, is this one, example 3. Absolute value of x plus 4 plus 3 less than 5. So this is subtract 3 from both sides. We have x plus 4 less than 5 minus 3, which is 2, and of course since 2 is greater than 0, it obey the theorem we are talking about. So we expand x plus 4 greater than -2 and less than 2, and then subtracting 4 all through will give us -2 minus 4 less than x plus 4 minus 4 less than 2 minus 4, and this is -6 less than x less than -2. Okay, -6 less than x less than -2, and on the lower line we have -6 somewhere here. Okay, joining it together we have -2 here, and this is the x-axis, and that is the number line represented in inequality. So this is how to solve absolute value inequality of this nature. Okay, so theorem 4 and 5. The next theorem is given as this one. If a is a positive number and u is an algebraic expression, then absolute value of u greater than a is equivalent to u less than minus a and u greater than a. So this is what we are saying here. A must be greater than 0. So absolute value of u greater than a imply u greater than a or minus u greater than a. Remember that u is always an algebraic expression, and if minus u is greater than a, automatically you have u less than minus a. And of course also if you have the slack inequality here, slack greater than, okay, it's the same thing as u greater than or equal to a or minus u greater than or equal to a, which is the same thing as u less than or equal to a minus a. Okay, dividing both sides by minus. So the sign changes because when you divide both sides by minus, the inequality sign, the sense of the inequality sign always changes, and that is how this one operates, and I believe it is clear. Okay. So let's see if we can have an example here. Example. Examples. Solve each inequality and express your answers and graph the solution. Solve and graph your solution. So for number 1, we have absolute value of 2x minus 3 greater than or equal to 2. Okay, here if you look at it, 2 is greater than or equal to 0. So whenever 2 is less than 0, guys, there is no solution. So here it works. So we have 2x minus 3 greater than or equal to 2. We solve this, or minus 2x minus 3 greater than or equal to 2. So we solve on both sides. So adding 3 here all through, we have 2x greater than or equal to 5, and that will give us x greater than or equal to 5 over 2, and that is x greater than or equal to 2.5. Okay, or solving this one, we have 2x minus 3 dividing both sides by minus and changing the sign less than minus 2, Adding 3 to both sides, we have 2x less than or equal to 1. Okay, minus 2 plus 3 is 1. So dividing both sides by 2, we have x is less than or equal to 1 is 0.5. 0.5, and then the number line can be given as this way: 0.5 and 1. And 2.5. So this is 0.5 here, and this is 2.5 there, and this is 2.5 less than or equal to yeah. So it's going to change to what we have over there. Okay, so which is x is greater than 2.5 and less than 0.5. So it is not going to join together, guys. So here we have less than 0.5, so it's less than, and the circle will be shaded, and this is 2.5. okay, greater than 2.5, so it's going to be shaded and it's going to point this way, so they don't meet. So this is x is less than or equal to 0.5, this is x is greater than or equals to 2.5. okay, so and that answers the question. So the solution set does not intersect there. They don't intersect, not like the other one which we have intersection. Okay, yeah, it's not like this one that we have intersection. Another example, example 2. Example 2 says absolute value of minus x minus 2 greater than or equals to 1. So since 1 is greater than 0, we have minus x minus 2 greater than or equals to 1. Adding 2 all through, we have minus x greater than or equals to 3, and dividing by minus 1 all through, we have x less than or equal to minus 3. Okay, so the second side of the inequality is minus x minus 2 greater than or equals to 1. So that will give us minus x minus 2 less than or equals to minus 1, and that is minus x less than or equals to minus 1 plus 2. That's minus x less than or equal to 1. So I'm dividing all through by minus, we have x greater than or equal to minus 1. Okay, so this can be combined to have, I don't think the combination of this can work. Let's look at the answer on the number line. This is minus 1, x is greater than or equal to minus 1, we point this way, and this is minus 3. So so x is less than minus 3, we also go this way. Okay, x is less than or equals to minus 3, x is greater than or equal to minus 1. So that is the number line representing the solution. And finally, we have the final example here. So taking a look at this example, we have example 3, 2x minus 3 over 2 plus 1 over 3 absolute value greater than 1. Okay, so and of course 1 is greater than 0, so we take both sides. 2x, combining the inequality in the first place, we have 2x minus 3 plus, this is multiply this by 3, multiply this by 2, everything over 6 absolute value greater than 1, and this can give us 6x minus 9 plus 2, everything over 6 greater than 1, and that can give us minus 9 plus 2, which is 6x. Minus 9 plus 2 should be minus 7, okay, over 6 greater than 1, strictly greater than 1. So then we can have both sides of the inequality. 6x minus 7 over 6 greater than 1. We have 6x minus 7 greater than 6. Okay, 6x is greater than 6 plus 7. And 6x is greater than 13. Dividing both sides by 6 equals x greater than 13 over 6, which is a 2 number 1 over 6. Okay, or minus 6x minus 7 over 6 greater than 1, which would imply minus 6x minus 7 greater than 6. Okay, and that is 6x minus 7 less than 6. Okay, so that is 6x less than minus 6. So 6x less than minus 6 plus 7, which is 6x less than 1, and that is x less than 1 over 6. Okay, so and we have the two solutions, and the graph can be given as this, in this way. So the first solution, x is greater than 2 points. We have 2 number 1 over 6 here. So x is greater than 8. So we shade it. This is x is greater than, strictly greater than. It's not going to be shaded. Strictly greater than, x is greater than 2 number 1 over 6, and this is 1 over 6, and we have x less than that. So x is less than 1 over 6, and that gives the solution of the inequality. And this is how to solve absolute value inequality, guys. So other examples, there are other examples you can look at in the textbooks, and of course you definitely get what you have. So other examples are examples in this form. Consider this example. If absolute value of u is less than a, if you have this kind of example, what you do is to square both sides. Okay, you square both sides, so and that will give us absolute value of u all square less than absolute value of a all square. Okay, and that is simply u square less than a square. Okay, and then you can take the square root of both sides. Okay, take the square root of both sides, you have u is less than a. That's the solution of this one. So if you have something of this nature, u plus a, u is always an algebraic expression, and a is a real number greater than 0, so less than absolute value of u. So square both sides as well. Square both sides. You have absolute value of u plus a all square is less than absolute value of u all square. So you have u plus a all square less than u all square. Okay, and if you are solving that, that is how you have the solution. It is a look at an example of the nature. So if this is this, okay, looking at this example, let me see if we can get an example of those forms, and then see if we can apply them together. So unfortunately there are no examples here for now, but that is how it works. So remember to subscribe to the next video and like our channel. Bye.